Welcome back. We are now going to begin to looking at if we are not given the order of a reactant, how can we determine the rate constant, or the concentration of one of the missing pieces. So we're going to still be looking at rate equals K, each reactant raised to some power. And we will need to use this algebraic relationship, rate 2 over rate 1, concentration 2 over concentration 1 raised to a power. Let me point out that in this algebraic equation, it really doesn't matter where you put rate 1 and rate 2, as long as your rate 2, it has concentration 2, is in the same level, meaning I could put 2 over 1 or 1 over 2, but if I have 2 over 1 here, I need to have experiment 2 over experiment 1 here. I could put experiment 6 and 4. I need to have 6 and 4 over here. I could have 4 and 6 and 4 and 6. It doesn't really matter. I just have to have the same experiment step. Rate of that experiment step needs to be on top, and the rate of the other experiment step needs to be on bottom, and it has to match. So in other words, rate 2, concentration 2. So this is referring to experiment 2 or experiment 1 in this generic, concentration 2, concentration 1. So it has to be the same data set that's on top and a different data set that's on the bottom. And this is a generic raised to the power. So M is the order of the reaction. Up until the example today, you have already been given the order, and that has to be one of the ways that you can determine and use the expression is you have to be given the order like we had been so far. You have to calculate. That's what we're going to do here. And lastly, you would get it from a data table. And we'll do that later on. We're going to use experimental data to determine the formula, and we're going to be taking the natural log of both sides to bring down the exponent. So we're going to use some of our algebra skills that we've learned through algebra class, and we're going to plug in some of these numbers, and we're going to take the natural log, or the natural log of the ln of both sides in order to determine the exponent value. That's really what the goal here is. The goal here is that we'll be given data. Okay, the data will be given. It will have a concentration and a rate. We'll be doing this in a laboratory experiment potentially, specifically those that are in person. So you will be collecting, you'll know the concentration, you'll be collecting the rate, how fast the reaction takes place. And once you know and collect this data, you can then plug this in and solve the order of the different reactants using the algebra I'm about to show you. Now this is in our notes, but I also want to point out that you would be given it would be given to you on an assessment, okay? And I also want to point out that if you go to your Schoology account, it is here. And if you go to the unit PDFs, it is right here. This is the Kinetics formula page. So we're going to use this formula page throughout the remainder of the unit. This page here we'll be using a little bit, mostly for homework 2 and forward. This will be what we do here, right here, is going to be for homework 1 and what we're about to start. So just so you know, that is in there if you ever need to refer to it, and then these other formulas we'll be using throughout the unit. Okay, so again, make sure that you're very careful. I'll point that out as we go, but let's look at example 7 together. Okay, so we know that we're going to ignore the products. We don't really care about that. So what's happened here is that we have one reactant, and we're going to figure out what the order is. In this reactant, we did 4 experiments, experiment 1, experiment 2, experiment 3, experiment 4. So they ran 4 trials. When I say 4 experiments, really the proper term would have been they ran 4 trials of the experiment. The first trial had 2 moles. This, remember, is concentration, and it took 0.34 moles per liters per second was the rate. So this data table is set up that shows concentrations on the top and rate on the bottom. Okay, and then here's the steps written out, but I'm going to actually physically show this to you or go through this with you so we can figure out the order. I find it extremely helpful to number these as experiment 1, 2, 3, and 4. Okay, experiment is probably a good word. You can use the word trial. It really kind of just depends on your definition and what your professor at the time, if you were taking this for a college course, would be looking at. So we know that we're going to have rate equals K. And if there's ever a subscript here, that just is referring to a specific reaction. So we don't need to put a subscript. We could say K1, but if there was several, we would want to specify. So we had a list of chemical equations, we might number them 1 through 5. We just have 1 here. So we're going to do that. And then remember that we're going to put our concentration of our reactants and then it's going to be to some power. We're going to call this m. It could be x, y, z, whatever exponent you want to use, value or exponent letter you want to use here. So we don't know the order because it doesn't tell us anywhere. Remember that we have to be told, we have to calculate, or we have to grab that from a data table, a graph, excuse me. So we're going to figure this out here. So we're going to use that formula that I showed you a moment ago, and we're going to pick any two experiments, okay? And if I divided up a classroom and I had several people do experiment 1 and 2, some do 2 and 3, some do 3 and 4, and some do 1 and 2, some do 4 and 2, and some do 4 and 1. So basically what I'm saying is I could divide the room up and we should all get very close to the same value here. Okay, so let's see how to do this here. So now we're going to use the fact that we know, we're trying to figure out what this is right here. Okay, and here we go. So if you recall, our algebra formula is rate 2 over rate 1 equals concentration 2 over concentration 1, all raised to some power. We would apply this to every reactant in order to figure out each reactant's order, because we're not told. Now, remember, it doesn't matter what I have. I could flip these, but they both have to be flipped, meaning that I have to have, if I could call it parallel or the same level, right? Whatever 2 here, I have to have 2 there. If I put 4 here, I'd have to have 4 here, and vice versa. Okay, so we're going to do rate 2 over rate 1. Doesn't matter. I could do 2 over 3. I could do 2 over 3, 2 over 3. I could do 4 over 2, 4 over 2. Doesn't matter. I'd pick one. So we're going to start by putting rate 2. So this is here. We're going to do 0.76. And we know that this is rate over rate, concentration over concentration. So to save time, I'm fine with us skipping units because we know the units are going to completely cancel. Okay, so rate 2 over rate 1. Make sure you're looking for the rate. And then we're going to do concentration 2, right? Concentration 2 over concentration 1. All raised to some power. Okay, this only has 2 sig figs, so we're going to carry it out with 2 sig figs. I know we didn't practice sig figs, but you may hear me refer to sig figs. Some years I've done it. Most years I do sig figs. In 2020 and 2021, we didn't do sig figs just because of COVID. So if you're hearing this at a later date, you will need to apply sig figs. Okay, let's go through the math here. Then we're going to take 0.76 divided by 0.34, and we get 2.2 sig figs. So there's 2 sig figs there. And then we take 0.3 divided by 0.2, and we get 1.5 to the m. All I did was divide these two and get that, divide these two and this to get this. We're going to take the ln of both sides. When we take the ln of something raised, what we're going to do is we're going to get a number on our calculator. So you should find the ln button, not the log, the ln button, please. And this is 0.78. The calculator has a bad screen, hopefully. That's an 8. Actually, I think that is 0.79 with sig fig, so I'm going to fix that, 0.79. I'm going to go grab another calculator here in just a moment, but let me finish this. And then the ln of 1.5, and that would be 0.41, and the m comes down when I ln both sides. Now we're going to solve for m, 0.78 divided by 0.41, and I get, with 2 sig figs, 1.9 equals m. So we're going to call that approximately equal to 2. So we will call this a second order, this reactant second order. So here we would finish up writing, we'd say rate equals K, square brackets, CH3, CHO to the second order. Now we can do calculations with this, as we will show you here later on in the examples.